Now students, let us see exploring geometrical figures class 8. So we are going to discuss exploring of geometrical figures in 8th class. Introduction. So children, we come across various concepts of geometry in our daily life. There are objects and actions that have direct and indirect connection with the geometry. These objects or actions have geometrical properties and applications. Now we can see some examples. Solids. Generally, here we have cylinder, cone, cube, sphere, pyramid. These type of all geometrical figures are connected with our daily life objects. Now congruency. Congruency shapes. Figure with same shape and size are called congruent figures. Or we said that shapes are congruent if they have same shape and size. Okay children, this is the main point. Once again see here the definition. Figures with same shape and size. Okay, that means the figures must be look like same in shape and same in size are called congruent figures. Or we said that shapes are congruent if they have same shape and size. So you can say so many examples. 2 cricket balls or 2 mathematics books of same class. Okay, like that you can observe the so many shapes which have the same shape and size. So many objects which are same shape and size are called as congruent figures. Okay, now in general we can say in our daily life audio CDs, postcards, and we can saw some geometrical type of borders which are seem to be like a congruency. So in that congruency they use just like polygons, rectangles, squares type of designs. Okay, let us see one by one. Examples of congruency shapes. So I said no, geometrical shaped garden. Yes, see this here we have rectangle shape, square shape. Okay, this type of patterns, you just these are all what congruent. These 2 rectangles and these 2 rectangles. See here. Okay, these two and these two. That means here indirectly this chapter is very important to design a just like these type of gardens. Okay, or this chapter is very useful in many branches. Okay, let us see in later. Now postcards also. Okay, these postcards seems to be alike, congruency in shape, that is same size and same shape. Now next, audio CDs. These are all look like a what? Same. Okay, same shape and same size. Now, very important topic here, types of transformations. So first one, flip. Regarding this congruency, so first one, flip. Flip is a transformation in which a plane figure is reflected across a line, creating a mirror image of the original figure. Okay, a transformation just like a transformation. This one is a transformation in which a plane figure, okay, for example triangle, rectangle, square, whatever it is, reflected across a line, creating a mirror image of the original figure. Okay, so let us see one example. Mirror images. Yes, see this here, this side and this side. Okay, these two are look like a what? Mirror image. Okay, this is treated as a line or a mirror. Then this is this one. Let us take this one is the mirror image of this one. Okay, now see this line just like a mirror. As next, this object is also a mirror image, so this square is a mirror image of original one. Once again here, actually this dot, actually it is a parallelogram, look like a parallelogram. This dot is at this corner, so whenever you see this object image in mirror, it look like this. Okay, children, so like this you can get. Okay, now rotation, one more transformation. Rotation means turning around a center. The distance from the center to any point on the shape stays the same. Every point makes a circle around the center. That full rotation is 360 degrees. Let us see example. Here see this. Here we have the two triangles, and this one is a just like mirror image. So if you draw a circle by using the compass, that the circle must be passed through these vertices. Okay, and again through B and again through C. Okay, here the center must be is the same from the given distance points. Okay, here A and B and C are the same distance from the center. Okay, so like this we can. Now let us see move without disturbing the figure. When we move figure from one point to another point, or does not turn it or flip it. Okay, children, so that means we have to move the object from one point to the another object without doing turning or flipping. Now see this like this. Okay, children, once again see this like this. We have to move the object from one point to the another point. Now let us see one more example. Angle PQR, move to from this position to this position. Again we got here again angle PQR, and if it rotate, then like this we get. Okay, in flip mirror image, so like this we got. So these are the transformations: move, rotate and flip. Now congruency. Once again here, if two shapes are congruent, still they remain congruent if they are moved or rotated. Once again, if two shapes are congruent, still they remain congruent if they are moved or rotated. The shapes would also remain congruent if we reflect the shapes by producing their mirror images. We use the symbol these three lines to represent congruency. Okay, children, we have so many live examples in our daily life. So maths textbooks of your class, or same type of cricket balls, or 2 1 rupee coins, 5 rupee coins, like that you can see that congruency in so many objects. Already we discussed it before only. Again, in geometrically we can see congruency in line segments. If two lines are congruent, if they have same in length. Okay, children, we have AB and PQ. They have same in length. That's why they are congruent in line segments. Congruence in angles. If two angles are congruent, if they have the same measure, angle AOB and angle POK. Let us suppose that these are 30 degrees, or 45 or 20 like that. So why? Because it seems to be like an acute angle like that. And congruence in triangles. Yes, two triangles are congruent if all the pairs of corresponding sides are equal, or corresponding angles are equal. So children, very important. Once again here, two triangles are congruent if all the pairs of corresponding sides are equal, or O or R corresponding angles are equal. Okay, so now that means their corresponding sides and or corresponding angles are equal. So ABC one triangle and its congruent triangle is PQR. So here AB is equal to PQ, BC is equal to QR, and AC is equal to PR. Okay. Now in angles also, with respect to angles also, here ABC and PQR are congruent. Here angle A is equal to angle P, angle B is equal to angle Q, angle C is equal to angle R. Now congruence in squares. If two squares are congruent, if edges must coincide with each other, like this. Now congruence in polygons. Two polygons are congruent if all the pairs of corresponding sides are equal and corresponding angles are equal. Congruent polygons. Here we have the same corresponding sides are equal, and corresponding angles are also equal. Very important here. Similar shapes. Okay, this is another important topic. Shapes are said to be similar if they have same shape but different in size. Same shape, look like a same shape but different size, small or big, short or tall, like that. And see here, two bottles, one is small, another is a big. And here similar polygons, one is small and other is a big. So here these two are seems to be similar. So similar definition is simply they are having the same shape but different in size. Okay, this is a small size, this one is a biggest size, like that. Application of similar shape. Actually this chapter is very useful in the engineering department and photography also. So let us see one by one. Engineers draw elevation plans similar to the building to be constructed. Okay, they have to draw a small plan or a small just like a small shaped figure which is to be constructed. Okay, and diagrams of science operators and maps in the social studies. Okay, in our daily subjects also, mainly in science, actually in laboratories, in factories, actually the operators are so big. Okay, so but the operators are in our textbooks shown like figures, small figures. So that's why this is very useful. And you have come across in proportion. Okay, that is similar to the original objects. Okay, application of similarity. So where we use it already discussed. Once again see it clearly. Engineers draw elevation plans similar to the building to be constructed. DTP operators draw diagrams on the computer with which can be magnified in proportion to the make banners. Okay, so we saw so many banners, small banners, big banners. They are look like same in shape but different in size. Okay, photographers makes photo prints images of same by enlarging or reducing without distortion is based on the principle of proportion. Okay, mainly in photography and engineering departments these applications are very useful. And diagrams of science operators already discussed, and maps in social studies you have come across or in proportion, that is similar to the original objects. Now one more important, dilations. The method of drawing changed or reduced similar figures is called the dilation. Okay, simply drawing is changed or reduced to the similar figures. Now let us take one x-axis, y-axis, and 1, 2, 3, 4, 5 units, and y-axis 1, 2, 3, 4, 5 units, and I draw here a rectangle. So its dilation is the biggest one, like this. Okay, small to big or big to small. Okay, let us understand like this dilation. Now symmetry, most important topic. Symmetry is of the three types. Okay, namely the line symmetry, rotational symmetry, and point symmetry. So let us say line symmetry. What is meant by line symmetry? The line which cuts the figures exactly into two halves is called line symmetry or axis symmetry. Some figures may have more than one line of symmetry. Let us see example. Lines of symmetry. So I am taking a butterfly figure and it has one line of symmetry. Okay? It divides this figure into two halves, exactly two halves. And letter A also. If you draw A, it divides, the line divides A into exactly two halves. So that's why A has only one line of symmetry and this butterfly figure has the one line of symmetry. Rotational symmetry. With rotational symmetry, figure is rotated around the central point so that it appears two or more times same as original. Okay, if rotated two or more times, it's same as the original. So that's why it is known as a rotational symmetry. The number of times for which appears is the same for the order of that object or order of the symmetry of that object, order of rotation symmetry of that object. Now let us see the rotation of triangle. Not like that, just I am taking that animation. So here the triangle, I am taking a equilateral triangle and these lines are just like medians and they are meet at a point. So through this point, if you rotate 1, 2, 3 in 3 times, it seems to be same to the original shape. So that's why this has order 3. Okay, rotation of symmetry of order 3. Again circle, rotation of circle. So can you say how much order of this rotation of circle, rotation of symmetry of circle? Yes, it has infinitely. So just for your understanding purpose, I draw only sum of rotational symmetry. It is center of point. Okay, so this point, if you rotate this how many number of times, if you get, we will get the same structure or same shape, same figure. Okay. Now point symmetry. It is very important. When a figure looks the same, either you see it from upside or from downside, that is from any two opposite directions, then it is called point of symmetry. If you observe an object in any two opposite direction, if the shape doesn't change, the figure doesn't change, then that is the point of symmetry. We also observe that some alphabets have point of symmetry too. Those are X, H, I, S, N and Z. Some alphabets which are having the point of symmetry X, H, I, S, N, Z. Okay, so these are the some important topics regarding this chapter. So we will discuss later in the next videos. Thank you.